Welcome to UXL, where you can learn new skills anytime and anywhere. Visit uxl.com to explore our full course selection. This lesson is part of a larger course. Check the video description below for a link to the full course where you can enroll. If you enjoy our content, please like and subscribe. For your convenience, the course cover displayed on your screen provides the complete course title and lesson title. Let's proceed with the lesson. Lesson: Avoiding bias and fairness issues in AI models. Avoiding bias and ensuring fairness in AI models are crucial aspects of maintaining ethical standards and compliance in modern workplaces. As AI systems increasingly influence decision-making processes, from hiring practices to loan approvals, the potential for bias can have substantial social and economic consequences. Addressing these issues requires a multifaceted approach that includes understanding the sources of bias, implementing practical tools and frameworks, and continuously monitoring and updating AI systems to ensure fairness. Bias in AI models typically arises from three primary sources: biased data, biased algorithms, and biased human oversight. Biased data often reflect historical inequalities and prejudices embedded within the datasets used to train AI models. For instance, if a dataset predominantly includes male applicants for a tech job, the AI model might inadvertently develop a preference for male candidates. This can perpetuate gender disparities within the workplace. Biased algorithms, on the other hand, may result from the mathematical structures and assumptions built into the model that favor certain groups over others. Additionally, biased human oversight can occur if the developers and operators of AI models do not recognize or address their own prejudices, leading to the implementation of biased systems. To combat these biases, professionals can leverage several practical tools and frameworks. One such tool is the use of fairness-aware data pre-processing techniques. These techniques involve modifying the training data to remove or mitigate bias before the model is trained. Methods such as reweighting, resampling, or transforming the data can help ensure a more balanced representation of different groups. For example, reweighting involves assigning different weights to samples to balance the representation of various demographic groups, thereby reducing bias in the model's predictions. Another effective approach is to use fairness constraints in the algorithmic design. Fairness constraints are mathematical formulations embedded within the algorithm to ensure that the model's outcomes meet predefined fairness criteria. These constraints can take various forms, such as demographic parity, which ensures that the model's predictions are equally distributed across different demographic groups, or equal opportunity, which ensures that the model has similar true positive rates for all groups. By incorporating these constraints, developers can create models that are more equitable in their predictions. Furthermore, employing interpretability tools can be invaluable in identifying and addressing biases in AI models. Interpretability tools, such as SHAP and LIME, allow developers to understand how and why a model makes specific predictions. By gaining insights into the model's decision-making process, professionals can identify instances where bias may be influencing outcomes and make necessary adjustments. Real-world examples demonstrate the importance and effectiveness of these strategies. For instance, a study conducted by Google on their AI systems for image recognition revealed a significant bias against individuals with darker skin tones. By implementing fairness-aware data pre-processing and algorithmic adjustments, Google was able to significantly reduce this bias, leading to more accurate and fairer outcomes. This case underscores the necessity of actively seeking and addressing bias in AI models to achieve ethical and fair results. Additionally, a robust framework for bias detection and mitigation involves continuous monitoring and evaluation of AI models. Regular audits and testing using synthetic and real-world data can help identify potential biases that may emerge over time. For instance, the AI Fairness 360 Toolkit by IBM provides a comprehensive suite of metrics and algorithms to assess and mitigate bias in AI models throughout their lifecycle. By integrating such tools, organizations can ensure that their AI systems remain fair and unbiased as they evolve. Engaging diverse teams in the development and deployment of AI models is another critical strategy for avoiding bias and ensuring fairness. Diverse teams bring varied perspectives and experiences, which can help identify potential biases and develop more inclusive AI systems. Studies have shown that teams with greater diversity are more innovative and effective in problem solving, leading to better outcomes in AI development. Therefore, fostering diversity within AI teams is not only a moral imperative, but also a practical strategy for enhancing fairness and reducing bias. Moreover, education and training play a pivotal role in addressing bias and fairness issues in AI models. By equipping professionals with the knowledge and skills to recognize and mitigate bias, organizations can create a culture that prioritizes ethical AI development. Training programs that focus on the ethical implications of AI, the sources of bias, and the tools and frameworks available for addressing these issues can empower professionals to actively contribute to fair and unbiased AI systems. In conclusion, avoiding bias and ensuring fairness in AI models is an ongoing and multifaceted challenge that requires a combination of practical tools, frameworks, and strategies. By addressing the sources of bias, employing fairness-aware data preprocessing and algorithmic constraints, utilizing interpretability tools, engaging diverse teams, and fostering continuous education and training, professionals can develop AI models that uphold ethical standards and compliance. As AI continues to transform modern workplaces, these strategies will be essential in navigating the complexities of AI and automation while promoting fairness and equality. This concludes the lesson. We trust you found this video informative and engaging. To enroll in the complete course, please use the link provided in the description below. At UXL, we are committed to your learning journey. Each course offers a certificate of completion, online support, and downloadable resource files to enhance your experience. If you found our content valuable, we invite you to like this video and subscribe to our channel. Thank you for joining us, and we look forward to supporting your continued pursuit of knowledge.